Have you ever been in or within earshot of a conversation about electricity or electronics and someone used the term continuity, but you didn't have any clue what in the Freddy's uncanny cinch knot they were talking about? Well, I'm going to discuss it today here on the Bad Mofo Show. One of my favorite tools is the multimeter. They come in a variety of shapes and sizes. This one in particular has a digital readout. It'll measure voltage, both AC and DC, resistance, capacitance, and more. But today, we're going to examine this device's ability to check for continuity. First, let's examine the word itself. In a broad sense of the term, continuity refers to 1. A state or quality of being continuous, 2. An unbroken coherent whole, and 3. Without interruption. A good way to illustrate this is with a drawing. Imagine this circle as a path for something to travel upon. We can say that the path is continuous, but it doesn't have to be configured in a loop. We can say that the path in between my fingers is also continuous. It doesn't even have to be a straight line. Again, we can say that the path in between my fingers is continuous. But what if we put a break in the path? We can no longer say that the path is continuous. So what is meant by electrical or electronic continuity? Electrical or electronic continuity is the presence of a complete path for current to flow. That path is composed of an electrical conductor. What is an electrical conductor? An electrical conductor is 1. A substance in which electrical charge carriers, usually electrons, move easily from atom to atom with the application of voltage. 2. An object or type of material that allows the flow of charge or current in one or more directions. Whoa, wait, what? Admittedly, this subject can seem complex. I could spend hours defining the vocabulary and dissecting the theory in order to cover all those electricity and electronics. But for the purposes of this video, it's unnecessary. I'll examine other facets of this subject in later videos, but for now, let's just say that electricity needs a path in which to flow, and that path is an electrical conductor. Metals are the most common electrical conductors, with copper being the most widely used. Aluminum and gold are two other popular conductors, although their IACS ratings, that's International Annealed Copper Standard, are lower. But that's for a different video as well. So how does the multimeter check for continuity? By way of the two probes placed on either end of the conducting path, the multimeter applies a small voltage to the conductor. It then measures the resistance across the conducting path. If the resistance in that conducting path falls within the range pre-programmed into the multimeter, in this case about 0 to 50 ohms, then the meter responds with an audible tone. If the resistance does not fall within that range, then the meter does not produce the tone. Let's head to the workbench and get some hands-on. Here I have several examples of conductors and non-conductors, also known as insulators. Can you pick which ones are good conductors and which ones aren't? I'll switch the multimeter to the continuity check function and test it to make sure that it works by touching the two probes together. I should get continuity here, right? Here we have some common 12 gauge house wiring. There are 3 wires in it, and each one of them is about 2 millimeters in diameter. Let's start with the wire sheathed in black. And the bare wire, and the white wire. Note that they are not connected to each other. If I touch the white and the black here, nothing. If I touch the white and the bare, nothing. And the same for either side. Okay, how about this short length of 3/4 inch copper water pipe? Here's a water valve made of brass, a copper alloy. Here's a piece of printed circuit board that came out of an old router of mine. Probably hard for you to see, but I can test where the routing goes. Move it. So far so good. What about this rubber band? Nothing. How about part of the plastic case that the router's circuit board was housed in? Nothing. Here's an easy one, maybe. This is a piece of scrap steel out of my old riding lawnmower. Notice that I've scuffed up the contact points that I'm about to use. But if I touch it in the rusty area, nothing. There's some homework for you. Tell me why in the comments that happened. How about a piece of dry wood? Nothing. Here's an aluminum ingot that I cast using my homemade metal melting furnace. How about this drinking glass? Nothing. How about if we pour some water in the glass? Still nothing. And nothing from the water either. This is an experiment for another video. Here's one that may not be so obvious. A light switch. Nothing, you say? Now, what's the point to all of this? What's the purpose of checking for continuity? Usually a person will check for continuity in order to diagnose a problem with an electronic circuit. For example, a vehicle may have only one headlight working, and I've ruled out the switch being bad because one headlight still works. After replacing the bulb in the headlight that's out with a known good bulb and discovering that it did not solve the problem, I can use a multimeter to check for continuity in the wires that connect the bulb to the headlight switch. Finding that there is in fact no continuity, and there should be, I then physically examine the wires and find that one of the wires has been chewed in two by some unsympathetic creature. Delicious. Another example might be if I'm trying to trace a wire from one exposed junction in a wall to another. Let's say there are 3 sets of wires in junction A and 2 sets of wires in junction B. If the wires are ran inside the wall, I cannot physically see them in order to determine which of the 3 sets in junction A matches up with either of the 2 sets in junction B. However, I can use a multimeter to test for continuity between them. When the meter buzzes, I know the wires are from the same set. And by process of elimination, I can determine which of the 3 sets in junction A do not go to junction B. There are many places where being able to check for continuity is useful. I've had this particular meter for about 15 years now, and I can't even begin to count the times that I've used it for that, aside from the other functions. If you'd like to add one of these handy dandies to your tool set, you can get one similar to this new for about $100 or maybe $50 for a good used one depending on where you look. And the only upkeep is occasionally replacing a battery or replacing a set of probes because you sat on the damn thing. I'm Mo Fogarty, and I'll see you on the next Bad Mofo Show.